us through Module 3 and Module 4. Dr. Magori, perhaps you can introduce yourself and you can provide a short introduction session for those who are in class to introduce themselves, and then you can start with the presentation. Please, welcome, Dr. Magori.
Okay, thank you, Mwamini. I am Dr. Magori Nyangi. I work with the Institute as a lecturer, and I'm an expert in water quality, water treatment, wastewater management. And in this training, I will be responsible to train Module 3, which is on water, industrial water use and reuse, as well as Module 4, which is on wastewater treatment. In fact, the two modules, the second module, I mean the fourth module, which is on wastewater treatment, is just a sub unit of this module that we are going to start today. So I think I can just go straight and we can start because we have a limited time, and now I can see there are almost 19 participants. So I will just share the slides. Yeah, I think the slide is visible to all of us. Is it visible?
Yes, yes.
Okay, yes. Okay. Thank you. So the module title is what use and reuse of water in industrial practices. We know that the trainer is Dr. Magori, myself. And in this module, we are going to cover various aspects, including we expect for the learners to be able to gain insight into the diverse categories of water use, water utilization, and various strategies that are for water reuse and recycling in industrial aspect, including advanced treatment technologies. As I said earlier, that this part of the advanced treatment technology, I think we'll just cover it in detail when we'll be, on the module 4. The second aspect that we expect all of us to understand is that the module will, the learners should be able to examine the economic and environmental consideration that will help managers to make informed decisions regarding water resource optimizations. So I think we have 2 hours. The first hour will just be for me to lecture, and the second hour will be for a discussion. The overview, what we are going to cover in this module is that I will start with introduction, and we'll look at industrial water utilization, water reuse and the recycling strategies. And also we will look on water treatment technologies as well as economic and environmental aspect of water use and the reuse in industrial context. So to start straight, that we know that water itself has various uses in industrial setup, but in most cases, the higher water usage does not necessarily reflect higher economic output. The high economic output for any industry always depend on the kind of activities or the kind of product that is expected from that particular industry. So to measure the water use, this one can be quantified by what we call the water use efficiency, which is the ratio of the dollar value added to the volume of water that has been used. In most cases, The purpose of having this, the water use strategies so as to minimize the amount of water that can be used within the industry is that to maximize the water use efficiency. The water use efficiency, in short, it implies that the value of the water that has been put into various uses within the industrial setup or activities that are carried within the industry. So you can realize, or you can see here, that this graph indicates how there is no direct relationship between the economic output toward the amount of water that is put in use within the industrial setup. This one depends on the kind of industry itself. As you can realize, with the blue color, the color, which is blue, it indicates the amount of water that is used by various industries. For example, for the textile industry, which is the first line here, it shows that it uses high amount of water, but the economic output, which is indicated by the red color, is too small. But when it comes to some other industries like finance or in IT, software, as well as those pharmaceuticals, it can show that there is high output compared to the amount of the water that is put in use within those industries. So the water use efficiency, this is just the sum of the efficiencies in the major economic sectors that is weighted according to the proportion of water withdrawn by each sector over the total withdrawal. And in comparison, when you compare the amount of water withdrawn in African countries compared to those in Europe, you can see that in Europe, it indicates that the amount that the efficiency of the industrial water use is somehow too high compared to those in sub-Saharan countries that are indicated by the orange color. But the two end, those from the African countries and those in Europe, the average, those in sub-Saharan African is, it indicates that the water use efficiency is too small or is too low. But what could be the reasons? There are various reasons to these disparities. One is due to the technological or infrastructure. We know that in Europe, they have high advanced technologies that can enable them to recycle and to reuse the water. The system are also efficient compared to those in most of the African countries. But also in Europe, they have a very good water management practices. The level of economic development is also too high compared to those in African. And the last one is the nature of the economic activities. We know that in Africa, most of the economic activities for, our countries in Africa, we depend on agriculture. So it means that the irrigations that consume high amount of water and that such water cannot be, or it is hard for it to be reversed or to be recycled. So the water use efficiency in most countries in African, especially sub-Saharan African, is too low compared to those in Europe. So the industrial water consumption, depending on the kind of industry, the consumption depends, as I said earlier, it depends first the kind of activities that is taking place within an industrial setup. For example, when you compare the German and the Tanzania on the way they consume water, that you can see the total water withdrawal in Germany is around 28.48, while in Africa, in Tanzania, is only 5.18. And in this 5.18, majority of it, or high amount of it, is consumed by the agricultural activities that consume around 4.69, which is almost 80-something%. While for the industries in Africa, in Tanzania, they consume less than 1%. So this one indicates that a high amount of water that has been withdrawn in Tanzania is directed to agricultural activities, which in fact, majority of people in Tanzania are depending on agriculture for the economical gain. But when it comes to Germany, you can see around 17.68 meter cubic per year that has been withdrawn is directly for the industrial activities, while only 0.4%, I mean 0.4 meter cubic per year is used for agricultural activities. So that one indicates how the variations in industrial water consumption between these two countries, between Germany and Tanzania. But what are the challenges that are facing Tanzania? Why we don't have high amount that has been withdrawn that can be put for use in industrial activities? There are various challenges. The first one is that due to increasing urbanizations, many people tend to move to big cities whereby water is directed to other uses and not to industrials work. The second one is that we lack water reuse and recycling system. As you can see, a very small amount of water that is put in use, only 5% is the only amount of water that can be recycled. While the third one is that there is high cost of water treatment technologies. In developed countries like Germany, they used highly technologies that can recover or that can totally recycle 100% of wastewater, and it can be put into use. Also, we do have a limited water resources. Now we can realize those challenges as to why the industries in Tanzania, they have we don't direct much of water that we are withdrawing from various sources. There are several challenges, water resources challenges in Tanzania. The first one, which is common, is due to rainfall reduction, and this one has been exacerbated by I can say is the first one. It can reduction in rainfall. This one can be due to climate changes, and the second one you can see for the rainfall reduction is that various studies have indicated that there is a reduction in rainfall by around 25%. So this one has caused the reduction in water resources. Also, the river flow reduction, reliable water infrastructures by only 56% reductions, or decrease water transmission losses by 37%, that much of the water that has been, that we are supposed to be supplied for various uses, maybe for municipal, for industrial, for agricultural, the water that has been treated and supplied by various authorities, around 37% of it get lost due to various reasons. And one of them is due to the use of the old infrastructures or pipes. And another reasons or another challenge is the agricultural water use that utilizes around 82% of all water that is withdrawn. So you can see plenty of water that is withdrawn for various uses is directed for agricultural activities. So this one make a declined or amount of water that can be available for other activity to be small or to be less. And you can see we can only be able to recycle and reuse 5%. Recycling, it means that maybe after you have used a certain water, in most cases, that water will turn into wastewater. So if we could have various ways of treating such water, we can be able to put it into use, but only 5% of it can be recycled and put into use. Also, another reason is due to the water-stressed land area. So what are we supposed to do especially for the industry to have enough water for their various uses? We know that the only way to have the sustainable water management in industries is to do what we call decoupling. Decoupling, it means that you have to maximize the amount of water, to maximize the output from the minimal amount of water that you have. So there are various strategies. The first one is to optimize production processes within the industries, which means you should also focus on the activities that you see they need water to some point, to those activities that may not need water, so that the water should only be used for production purpose. Another strategy is to have what we call the smart water management. In smart water management, it implies that you may install various systems within the industries, such as those which can detect leakages. We can also we can rethink of using the what we call the closed loop system that minimizes the amount of that minimizes the amount of water that is put into use, and we minimize the amount of water that can be lost. The third strategies is that we need to characterize the industrial effluent. This one is very important because for the recycling and the reuse of the water, we need sometimes to understand the kind of composition of the wastewater so that we can apply the appropriate method for their treatment. This aspect of characterization of industrial effluents is only responsible to understand the best way of treating a wastewater before it can be put into use. So in short, we can say the decoupling that ensure minimal use of water and the maximum product of it, we need to have those three main strategies. First, to optimize production processes, to use smart water management within the industries, as well as to characterize the industrial effluents. We know that there are various uses of water in industries. One can be for cooling purposes, for processes, for manufacturing, and the boiler. All these uses differs. The kind of water that can be used for those mentioned activities differs in terms of qualities as well as the quantity. So identifying the quality of water that is put into place can also enable us to know to what activities are we supposed to direct that water for use. And this one can be quantified, or this one will help to determine what we call the water use intensity. The water use intensity in industrial context, it refers to the total amount of water that is put into use over unit of output or area. I can say this is just the amount of volume of water in relation to the product expected. For example, if it is the industry for that manufacture cars and whatever, this can be quantified by considering the amount of water to the number of cars that can be produced once you used a certain volume of water. The essence of now this module is that we should be able to understand how we can minimize the water use intensity, because the higher water use intensity in some cases it indicates inefficiencies within the industrial setup. And one way of ensuring that we minimize the water use intensity is to replace blue water with rainwater or non-conventional water. By blue water, what do we mean? Blue water is the common water that we are using. It can either be from various sources like surface water or groundwater from the wells and whatever. or even the water that is supplied by the various water authorities. So by replacing blue water with rainwater or non-conventional water, by non-conventional water, this is, I can say, is just the water that maybe the one that has been used and it became contaminated or polluted, or it became waste, and then you reclaim it for further use, or you do treatment of such non-conventional water. So here we can use we can replace the blue water that is, in most cases, they are expensive, with rainwater through harvesting rainwater, and by treating the wastewater within the industrial setup and put it to use. So the purpose here of the water use intensity is that we would prefer to minimize the water use intensity within the industrial setup. But by reducing this water use intensity, it may, in another way, it may lead to increased production cost, because sometimes, if maybe assume that you want to, again, to put the non-conventional water into use, you will need to have some technologies, systems of treating such water, and this one may also increase the cost of productions. There are various, I can say, in industrial setup, the water demand or the amount of water that is required within the industries. I'm sorry, I'm not sure if, okay, here in this slides that we know that in industry, various industry may have different water demand, but the water demand depends on various factors. The first key factor that is to why industry A or industry B could have different water demand is due to the production volume. This it implies that when you expect to have high output from your industry, we also expect that you will need high amount of water to produce such amount of units expected. Also, the water cost is another determinant, that when the cost of water is highly or is expensive, most of the industry will find the way to minimize their use and to have a low water demand. And another factor or another determinant is the water efficient technologies. For the industry that have efficient technologies, such those of detecting leakages, those that can recycle the wastewater and whatever, it means that a very small amount of water that can be put into use will be recycled and again be reused. And this one, it implies that even the water demand will be low. Another factor is the environmental regulation. So coming from the water use, we have seen various aspects of the water use, the strategies or the factors that may cause the high water demand within the industrial setup. So we should turn ourselves into the water reuse and the recycling strategies. The water reuse, in short, it means that once you have water in the industrial setup, the water that has been abstracted from various sources, as I said before, the source can be either from supplied by the municipal, the groundwater, the surface water, or whatever. We know that after it has undergone through the industrial activities, there is a chance that that water will become waste. It means that the water will be polluted. So this water cannot be reused for other activities within the industrial setup. And this water, most of the industries in developed countries, they tend to discharge it into environment. But there could be another way of making sure that the water that you put into use within the industrial setup can be reused. And for the water to be reused, is that it needs to undergo several steps. First of all, we need to collect such wastewater, and it can be directed in various stages of treatment. So in treatment, you can see the first step of wastewater treatment. This one, it can just minimize the levels of those pollutants, but still that water may not be safe for for further use within the industrial setup if you may not be able to put it into the advanced treatment techniques. As you can see here, when you put it into additional process for recycle, this one, it implies that you may apply the advanced technology so as to ensure that all the pollutants within the wastewater have been removed. Such water can be recycled or can be reused for, it can just be for the same purpose or for another uses within the industries. But from the first step of treatment, if the water has not been, the pollutants within the wastewater have not been reduced to the level that can be further reused within the industries, then such water can be discharged into the environments. But there are some policies and guidelines within of the governments that requires all the industries to have the treatment systems within their industry, so that even the water that is going to be discharged is safe for the environment. But we have several steps to follow in order to make sure that we put the water into use. The first one is, first you need to assess the water use, the kind of activities that is consuming water within the industries, and the kind of wastewater that is generated. Also, you need to characterize of wastewater. You need to identify the levels of pollutants, the kind of pollutants, so as to know what kind of treatment system should I use. Also, you need to integrate the water use and reuse, water reuse and recycling within the existing systems, that you don't need to have a separate system to enable the process of reuse and the recycling. This one can just be integrated within the existing system. Also, you need to carry what we call the cost-benefit analysis, because you for the industries, most of the industry depends on a certain profit. So sometimes when you integrate the treatment infrastructures within your industries, they may have a very high cost to the point that you may not benefit from the product that you are producing. So you should also carry what we call the economic as well as the environmental analysis. And lastly, you need to monitor and maintain the system if it is operating according to the intended application. So one of the key aspects of the water use and the reuse or water utilization in industrial setup is called the closed loop system. The closed loop system, this one is just to ensure that any water that you put into use will remain or can be recycled or can just be reused in a several cycle within the industries. Is that you minimize the amount that you are discharging and you maximize the amount that is put into various uses within the industries. So it can have a very small, I have tried to make it very short and clear so that we can all understand. I can open another document here that shows the flows of closed loop water system. Okay, here we can have a closed loop water systems as well as open loop water systems. Most of our industries in Tanzania, we are using they have adopted the open open loop water system. In an open water loop system, it means that the water that have been put into use within the industry, there is no any recycling or any reuse. So all the water, once it is turned into waste, so yeah, I mean, it just gets discharged into the environment. But once you apply the closed loop water system, you'll ensure that water that you put into use will just remain within the industrial setup, within the various activities within the industry. The water that has been treated can be reused for the same purpose, or it can save for other uses, but within the industrial setup. So this is just a circle showing the closed loop water system. As you can see, here is the starting point and the water source. You can abstract water from various sources, can be groundwater, surface water, or whatever source. This water can be channeled into various tanks, storage tanks, or it can be directed to various uses within the industries. Once the water has been used in the industries, we know that it obviously turn into waste because it becomes contaminated by various by various pollutants within the industry. So it will turn into waste. So you need to have also a system of collecting such water, and the system of collecting that water, wastewater, should be directed to your, the treatment points. At this treatment point is where now we expect that all those pollutants that have been contaminating your water again become removed from the water and make water again safe for further use. I can open here another chart that shows the closed loop water system. I think we can all see the chart that here you have the water source that can be directed to, the water source that can be put into use, and this water may turn into waste. That wastewater, now you need also to collect it and send it to or channel it to treatment facilities. And after being treated, you need to check for the quality. If the quality meet a standard of further use, the water can be reused. But sometimes if the quality is not of that high or expected one, the water can be either discharged or sent back for further treatment. But as I said, in Tanzania, we don't have, it is not common to find industry with this system that can minimize the amount of water that is, that can be used within the industry. But there are various reasons. There are various obstacles to adoption to water reuse and the recycling in our country. The first one is that we lack those advanced water technologies, and the reasons behind this one is due to their cost, because some of them, like reverse osmosis, they are too costly to the point that the capital that may be required to have a setup or to have the wastewater treatment within the industry is become difficult to meet. And the first one is due to lack of fund, which can also implicate the availability of the advanced water technologies. But the another reason is awareness. Maybe some of the I can say the industry managers and whatever, they are not aware of the benefit of having the water the water reuse and recycling within the industrial setup. And sometimes we fear to comply with regulations and so on. So I can say these four are key obstacles that prevent our industry from adopting to the water reuse and the recycling. And as I said that the two modules, this module 3 and the module 4, the module 4 will be like an extended of module 3, is that will focus on wastewater treatment process. Or one of the key aspects for the water reuse and the recycling is to have the wastewater treatment system within the industry. So this is, it indicates how the system operates, how the wastewater treatment process operates within the industrial setup. I will not go into detail on this process, but we'll have a time to discuss in deep this water treatment process. But in short, here it indicates it always depends on the kind of the activities, on the kind of pollutants, on the characteristics of wastewater that has been produced within the industry. But the general setup is like the way we can see that you have the collection tank, you go to the screen chamber, you remove for the industry that produce high amount of oil and the grease, you should have a tank that can remove them, dosing for coagulations and the equalization tanks for flocculation. And then you go down, you will find a step where you will need also to remove some of the suspended particles by doing what we call the filtration. Then here you can go for aerations and the secondary class.
Hello, Momini.
Hello?
Yeah, you are muted,
Yes.
Momini. Okay. I can see
Sorry,
the presenter.
you can't hear the presenter. I think he has dropped off. Magori, yes, I think it was a connectivity issue. I'm just checking with him. Apologies. Okay. Oh, he's still here. Dr. Magori, can you unmute yourself? He's on the call. Let me try to unmute him.
Hello?
Yes, we
Yeah,
lost you.
yeah, I'm sorry, the power went off, so, but I've connected again.
Okay, we'll give you a few seconds to set up.
Yeah, I think, can you see the slides?
Personally, not yet. Now I can. Yes.
So I think it is stopped at this slide. I'm not sure at what point. Did you go through this, the strategies and obstacles? Okay. So, yeah, I think now we can proceed. Is that yeah, as I said, one of the key aspects of the water use and the reuse is to have a closed loop water system. This closed water loop water system ensure that the amount of water that you put into use, you maximize. It get maximized within the industrial activities, that we minimize the amount of water that can be discharged as a waste. So I think we have gone through the 𝐀𝐶𝐿 and see the main steps, and also we saw that in most of the developed countries, they are not adopting the water reuse and the recycling because of various reasons. One can be due to funds, scarcity, the shortage of funds. We lack the advanced water technologies, also the awareness, as well as the compliance to regulations and the guidelines. So the rational use of water, one is that we need to have the wastewater treatment process, wastewater treatment facilities or systems within the industry setup. This one will ensure that we discharge a very minimal amount of water while we maximize the amount of water that can be reused within the industry. Also, for sustainable water management practices, that we should have various aspects or various factors that should be well considered so as to ensure that the water within the industry become sustainable. The first one is that we need to conduct water audits. By water audits, it means that you should understand clearly every single drop, the purpose of every single drop. I mean the usage, the value of water that you are using within the processes of the industry. So and also we need to integrate the rain water harvesting systems. This one will also ensure that we utilize or we maximize the amount of water that we get access to alternative sources of water for the industrial activities. Also, we can adopt the use of saline and the gray water. This one cannot be used directly, but it can get into use after being passed into treatment to minimize or to remove the amount of salt that can be present. Also, we should also encourage the use of eco-friendly chemicals and materials. Once we have a minimum amount of harmful chemicals within the industries, it means that even the treatment process will be minimal, and it become easy for the water to be reused. Also, we can implement the various conservations measures. But as I said before, you can decide to have facilities for water use and the reuse within the industrial setup. You should also conduct what you call the cost-benefit analysis of water reuse. What could be the benefit of you having such system in your industries? Here, you need to evaluate the financial cost, the capital cost of implementing water reuse systems against the benefit they provide. So for the capital cost here you should be in a position to do some calculations by considering the cost of treatment systems, treatment facilities, infrastructures like pipes, storage tanks, and whatever, as well as the installation and the engineering cost. Also, you should consider the operation and the maintenance that include the energy consumption, the chemical and materials, the cost for chemicals and the materials, and as well as the labor and the technicians' charges. The two we will give the total cost of applying such a treatment. And you should also be in a position to consider the financial benefits. Here, the benefits where are you expecting to benefit from are using reuse and the recycling systems. One can be by minimizing the cost of purchasing water. Here, it will help you to save some amount. And also, we know that there are some charges that for the industry should pay for disposing wastewater. Once you have these systems, you will be in a position to avoid this kind of charges. And also, sometimes you may incorporate the facilities that will help you to recover some resources within the wastewater, such as the biogas, the manure, and so on. This one can also be put into markets and it becomes one of the source of income for your industry. So those are the benefits. But how do we calculate the CBA? Here, there are two main indicators. One is the payback period. After how long you expect to have benefited from using the reuse and the recycling system. This one can be calculated by using a payback formula that is a total capital cost assume that the cost of installing treatment systems in the industries is 5,000 USD, and you expect the annual saving of having that system, maybe through minimizing the cost of purchasing water, the amount that will save, the cost of disposal, and even the revenue that can be generated by selling the resources that have been recovered. Maybe it is 1,000. So it means that when you take that 5,000, that is total capital cost, divided by 1, the annual saving, that is maybe 1,000, we expect that you will get a payback after a period of for 5 years, you'll be able to get a payback. But another key indicator whether you are benefiting of by using such system is by considering the net present value. The net present value, which is NPV. The NPV is calculated by taking the benefit at a time T, the benefit of you having such system after maybe it can be annually minus the cost at a time T, the cost that you have incurred in running such a system, divide by 1 plus discount rate over, time period, after how long. So after you have calculated the NPV, how do you make now decision? If the NPV value is greater than 1, then it means that you can profit from having reuse and the recycling system within your industries. But if NPV is 0, here it implies that there is no net profit. But if the NPV is less than 0, then you will be getting loss, and it means that there is no need of you adopting such a system within the industries. So Another aspect of water use and reuse module is on economic and environmental considerations, and how do we now reduce water footprint? By water footprint, it means this is just the amount of water that that is needed for various uses within the industries. In order to minimize the amount of water that will be needed for various activities, there are various strategies. I think we have talked about this one, but one is through process optimizations, water recycling and reuse, employee training. You can train them on the best way of saving water or of using water. And you can have a smart systems within your industries, like those that can detect leakages. And because we know one way of which the water can get lost within the processes is through leakages, and also some water that are lost maybe through evaporations and whatever. We can have a system that may also do what we call the condensations, because we know plenty of water can be lost through evaporation when it gets heated. Now, as we saw earlier, that most of our industries fail to adopt the water use and reuse or recycling systems due to lack of funds. But there are various ways by which we can have access to funds. The first and the important way is through, from the government or from various agencies like Africa Development Banks, or through the corporate social responsibility, and through various corporate agents. Now, for the sustainability of not only the industry, but for economic or for environmental saving or gain, we should, in order to make sure that we adopt or we use the water use and the recycling appropriately, we should be in a position to engage various stakeholders. And here, how can we be in a good position to assure that various stakeholders get engaged? The first way is through sharing. We share what we are doing. All the processes, the activities. If maybe you have adopted a certain technology within the industry setup, we should share this kind of information about water management practices. The second way is by engaging. Here, we must also engage the local stakeholders in some points of decision-making processes. Maybe if you want to use a certain wastewater treatment plants, or you expect that you will be discharging, or the certain water has been treated to a level that can be used for irrigation purpose and whatever, that water, once you engage local people, okay, you can be in a position maybe to allow them using such a water for their other uses. Another is to collaborate. Here we can collaborate with different NGOs, maybe to attract funds, to make them aware of our activities. And if maybe you are recycling, or you expect that your systems, the reuse and the recycling system, also you have, maybe you are there is some resources that you are recovering from such a process, then you can be in a good position maybe to sell such a resource. sometimes we should be in a good position to prepare for emergencies. There are different emergencies that can arise, and this one may affect all processes of the industries. One can just be due to flood. As you can see, these pictures here indicate the flooding. We know floods can destroy the buildings, and they can affect the whole process of that is taking place within the industries. Also, some other emergencies can be from fires and burning and whatever. So we must be in a good position to prepare ourselves for such emergencies. But how? The first one is, first you need to assess the risk. We should be in a good position to see what kind of a risk can maybe occur. If the second one is for the response strategies. Okay, in case, if maybe for the case of flood, what are the responses that I should be able to take? And the last one is to train, especially the workers within the industries. You should train them. You should make them aware of all aspects of all the responses that they should take once a certain emergency arise. So for the efficient water reuse, there are various technologies. I will not talk about the treatment technologies. This one will be in a position to cover it. But just to understand that there are various treatment technologies, and each technologies depends on the kind of or the characteristics of waste that you are producing within the industries. We have three main categories of technology. One could be those of physical technologies. We have the biological technology, means of treating wastewater. And we have also the chemical means, or the chemical waste. So just to mention them, we can have the sedimentation, filtration, extraction, adsorption, distillation, membrane, which is advanced one. We have the electrolysis. So in short, there are so many ways of treating or of removing pollutant within the industrial setup and make water safe for further use. But each one of these methods have setback. They differ in cost. Some of them require skilled personnel to use them, and so on. So in short, there are so many ways, methods by which can be used to ensure that we maximize or we adopt to water recycling and reuse. Now, how do we choose the right technology? It will depend, as I said, it will depend, one, on the characteristics of water, wastewater, because each pollutant or each composition, the composition of the wastewater will require a certain technology for their removal. And another one is the intentional use, the intended use of water. If water, you want it to be a class 1, maybe for production of like drinks and so on, we know there you will need class 1 water. This class 1 water, you should be able to pass it into the advanced technologies like ROs, so as to make sure that you remove all kind of salt or all kind of ions that could be present in such water. And another ways by which you can select the right technologies is, it will depend on the treatment cost. We know that most of us would prefer to minimize the cost, the capital cost of running such systems. And another one is the regulations. Sometimes the regulations would require you that you treat a water to a certain levels, and this one you will now be responsible to make sure that you use a certain kind of method so as to meet the requirements as per regulations. So that marks the end, but to acknowledge the acknowledgements you can see there. And thank you for your attention. Thank you.
Thank you so much, Dr. Miguel, for that insightful presentation. So the question now mark almost the end. So it's time for Q&A. Everyone, if you have questions for Dr. Magari, comments, it doesn't necessarily have to be questions, it could be knowledge sharing. So please welcome further input. Yes. Any volunteers, or should I start calling out names? I guess I'll just start with names. So, Consider, do you want to go first?
Yes, good afternoon. Yeah, I would like to thank Mr. Magoyo, right, for the good lecture. I think I don't have much of the comments on the lecture. Thank you.
Okay, thanks, Consider. Up next is Damas.
Thank you, Moamin. Yeah, thanks for Magoyo for the good presentation. Yeah, well covered and too detailed. I know if you have, I'm not sure if I missed this. Do we have an example of industry which is treating wastewater here in Tanzania? I'm not sure if you have explained it or not. That's just for me. Thank you, Moamin.
Hello.
Yes, please.
Yeah. Okay. I think you want to know if there are any industry that is treating, or is, in short, you can say is reusing or is recycling. It is wastewater, isn't it?
Yes, that's what I meant.
Okay. Of course, there are various industries. One is backtracers. Another one, there is a certain industry which is located in Arusha. It is for processing bananas. It is called Banana Investment Limited. And even the Tanga Fresh, the one that are producing the milk and the dairy processing, they are also using this recycling system. Those are the ones that I'm sure of.
Yeah, okay, thank you. I hope we will get a chance to visit Cresa during the face-to-face training.
Okay, I'll take that into consideration and see how to plan the day because, yeah, it's not an issue. It's not an issue. I'll just talk to the trainers how we can structure it so that we can try to incorporate that. No problem. But
Okay, thank
we
you.
will visit an industry for sure that does issues related to wastewater treatment. Okay, so up next is Elizabeth. Welcome.
Thank you very much for a very insightful presentation. I think I don't have any comment to add.
Okay, thank you, Elizabeth. Fred? Yes, Fred.
Yes, hello.
Ah, Mr. Rema. Oh, okay,
Right.
you.
Thank you very much.
Okay, welcome.
Maybe I misquoted you. Anyhow. Momini, thank you very much indeed, and clear, elaborate, eloquently spoken, and I don't have any issues. Thank you very much indeed.
Okay, thank you so much, Mr. Rema. Jasmine, Musa.
Yes, good afternoon. Thank you
Good
very much for
afternoon.
the pleasant presentation from Dr. Magori. I just love his voice, energy voice. Thank you.
Jasmine. Anyways, Dr. Magari, your compliments, I guess. Okay, he will not respond to that, I guess. But thank you. Indeed, Dr. Magari's presentation today was very energetic. I must agree with you. Kennedy, is it diesel or diesel? But Kennedy.
Thank you again, Mwamini. Kennedy Mapunda from Atawas. Actually, my comment to the lecturer, the presentation was quite engaging. Despite the weather, I was able to fight through the sleep. And I've gained a lot of knowledge today, and I'm grateful for that. Thank you very much.
Thank you, Kennedy. Lamek, up next. Yes, Lamek, you can unmute.
Oh,
Hello.
thank you very much, Dr. Mago. Can you hear me?
Yes, we can. Oh, okay. That was Lamek's contribution. So, Sophia.
Thank you, Dr. Magori, for the good presentation. I think I have nothing to add.
Okay, Susanna. Susanna, anything from you? No? Okay. Last but not least, William Gilly.
Thank you,
Oh,
thank you,
Susanna.
Mamini.
Oh,
Yes,
yes.
thank you, Mamini. The presentation of Mr. Magoja was very, very powerful and very explanatory. Maybe I can ask it in area of how to use the right technology in water treatment. During his presentation, I heard that say we can choose a technology according to the water composition, according to the wastewater and its composition. So I want to know, what about the wastewater we saw there when we go to the site visitation? Is it �WAMI, Uluvu? So such kind of water, which technology may use there to treat that water?
You mean the one from the river, right?
Yes.
Okay. Dr. Magari.
Okay, thank you. Just to make it clear, we can have the wastewater. The one that we are trying to discuss here is the wastewater. The wastewater is the one that has been contaminated by high amount of those pollutants that are also categorized into physical, chemical, and as well as the biological. It means that their composition is too high in water. But when you talk about maybe the water that is treated from the Ruvu River, that is not considered as a wastewater. So the one that she asked, there are various ways, but normally there is what we call the conventional water treatment systems. It means that there are various stages, there are various steps of which those different pollutants in water can be removed. Assume that in your water source can be contaminated by just the physical aspect like soil, silt, and so on, the suspended solids and whatever. But it can also be contaminated by some dissolved ions, chemicals, heavy metals, and whatever. But it can also be contaminated by some microorganisms, biological organisms. So all those three categories can have different ways, different approach of removing them from water source. So when it comes to the conventional water treatment, the system is composed up of all those different ways that have been hyphenated or combined together to make sure that all contaminants are removed. For example, you have the first step of screening, that is just for the removal of large debris and so on. You from the screening, you go to coagulations, the coagulation and the flocculation. This one removes the suspended, the colloids, you can say the colloids that are present in your water sample. From there, you go to sedimentation, where you leave that water to settle, those particles to settle down. Once they get settled, then they can just be removed. But sometimes some of the particles may still remain in water sample, in water source. So that water is now again allowed to pass into the filtration in order to make sure that all the particles that are present in water again get further removal. So I can say from there now, water becomes disinfected. And here we always use the chlorine, whereby we disinfect. The disinfection is just to make sure that water becomes free from pathogens or the disease-causing organisms. So I can say there is no a single technique or a single method that can treat water. It depends. That's why I said it will depend on the kind or the composition or the characteristics of such water. For the water from Ruvu, we use that conventional treatment. We don't have the advanced techniques of treating water.
Thanks, Mr. Magoja. I'm well understanding now.
Thank you, Susanna. So thank you, Dr. Magoja, for that clarification. Last but not least, William.
Hi. Thanks, Dr. Magori, for a great presentation. I just have a challenge for all of us. There was a question that was asked, and Dr. Magori answered it pretty well. To my understanding, many industries, particularly those in food processing and manufacturing, actually do or are supposed or are ought to be treating their effluent water prior to discharging. Now, the issue is normally with the regulators. Do they normally, or do they do their jobs? That's a question that everybody's got to kind of ponder and perhaps help so that the requirements or the regulations or the guidelines that are set forth by our regulators are enforced. And that's my comment.
Thank you so much, William, for that thought-provoking challenge. Before Dr. Magori responds, I just want to confirm, Nelson, I noticed you joined almost close to the end. I'm not sure if you managed to follow the conversation and if you have any inputs. Nelson? No? Okay. Okay, so maybe just, oh, he's there. Okay. Yes, Nelson, you can speak, you're unmuted. Okay, nothing from Nelson. Okay, so Dr. Magari, I don't know how you want to respond to William's comment. Dr. Magari, not sure how you want to respond.
Okay, yeah, okay. If what he said is clear and true, that the difference that we have between us developing countries to developing countries is not that we don't have, it doesn't mean that we don't have the regulations and the policies towards the discharge of wastewater. We have them and they are clearly stipulated, but the issue is on how they are reinforced. That is the difference between us and the developed countries. For example, we have the Environmental Management Act, EMA number 20. This is of 2004. This one mandates industry to treat wastewater before disposal. But unfortunately, some of the industries still or even do not have the treatment facility systems within their industries. And this act also establishes legal frameworks for pollution control, including wastewater discharge. Another regulation that the policy that we have is that of the Water Resource Management Act. This is of 2009, number 11. This also regulates water use, including wastewater discharge into water bodies, and that for the industry requires permit for wastewater discharge. That's why I said that there are some also penalties, or there are some payments that for you to discharge water, you should be able to pay. But unfortunately, the enforcement of these laws is quite different. Also, I can say we have so many laws and regulations. The TBS have set the limits for industrial and municipal effluent before discharge. But if we don't have the treatment system that operates to the required level, it means that we can discharge the water that is not, that does not meet as required standard. Also, the NEMC, the National Environmental, the NEMC, I think we all know NEMC. They are the ones that are responsible to check if the industries meet the requirement for the wastewater discharge. But sometimes due to unforeseen reasons is that most of the industries do not comply with the policies and the regulations that we have. So that is the situation.
Okay, Dr. Magari, thank you so much for responding to that.
Momini, we can't hear you.
I just noticed I was on mute. Thanks for catching that. Yes, I was saying, so this marks the end of the Module 3 webinar. We look forward to seeing you all next week. Dr. Magori, thank you for being fantastic for the energetic presentation. I think you have received your compliments from everyone. It was very insightful, very engaging. Just in case anyone has any more questions, we'll be seeing Dr. Magori during the in-person training scheduled in less than 3 weeks. So we hope you can all participate and engage directly with Dr. Magori. But other than that, I wish you all a great week ahead and see you next week.
Goodbye.
Bye, everyone. Thank you.
Thank you, Mami.
And wrap
Thank you, Mr. Mago.